hard to believe that something so enormous is in the water around Florida and we don't even know it.
Were put in place for Miami Beach and Fort Lauderdale, putting limits on businesses and on visitors.
The waters off Florida's Gulf Coast have long harbored mysteries, from tales of ancient shipwrecks to unexplained geological phenomena. But what has recently been discovered beneath the shimmering blue surface is unlike anything marine scientists or government officials have ever encountered. A series of vast, terrifying sinkholes, some hundreds of feet deep, have opened up unexpectedly on the seafloor, drawing an immediate and unprecedented response from federal authorities. Within hours of verification, the United States government made the dramatic decision to completely shut down maritime activity along a significant stretch of Florida's coastal waters. The discovery has sent shockwaves through scientific, environmental, and security circles. Before we start, smash the like and subscribe buttons for more updates. The chain of events began quietly, with a routine geological survey being conducted by a marine research vessel affiliated with the National Oceanic and Atmospheric Administration (NOAA). The team aboard had been monitoring an area previously flagged for minor tectonic activity, nothing alarming, just slow shifts in the seabed that typically occur over millennia. Yet the instruments on board began returning anomalies that defied existing models. Pressure readings, sonar imaging, and geochemical sensors all began to spike in unison. A survey drone sent below revealed the first shocking image, a yawning cylindrical void that descended vertically into the earth like a gaping mouth. It measured nearly 400 feet across and plunged deeper than any previous sinkhole found in marine sediment layers. As researchers processed the images and data, more sinkholes were discovered along a bizarre fault line that no existing geological map had charted. These weren't ordinary depressions formed by gradual erosion or water displacement. These sinkholes appeared almost violently torn open, as if something from deep within the planet had suddenly surged upward and then collapsed. The structures surrounding them weren't composed of typical limestone or coral, but of a strange, highly porous black mineral not previously documented in Florida's ocean floor strata. What alarmed scientists most was not just the size or composition of the holes, but the energetic activity surrounding them. Some of the sinkholes emitted heat despite their depth. Others showed signs of seismic microtremors, indicating ongoing geological instability. Within hours of these discoveries, the situation escalated from scientific curiosity to national concern. A top-level security briefing was convened between NOAA, the Department of Defense, the United States Geological Survey (USGS), and the Department of Homeland Security. What they concluded was chilling. The sinkholes might be interconnected, part of a larger and active subterranean system that could, under certain conditions, destabilize significant portions of the ocean floor. If the fault system underlying these formations were to shift further or collapse entirely, it could trigger tsunamis or cause widespread coastal subsidence, threatening the heavily populated regions of Florida's Gulf Coast. Federal agencies coordinated an immediate maritime exclusion zone stretching more than 300 miles along the west coast of Florida. Civilian vessels, fishing operations, and all commercial maritime routes were rerouted or suspended indefinitely. Satellite and naval surveillance were deployed to monitor any changes in the ocean's topography. Meanwhile, deep-sea submersibles began mapping the newly discovered formations, collecting samples, and trying to understand what could have caused such an abrupt emergence of catastrophic voids. The implications were staggering. This was not a localized geological quirk. It was a sign of something far more massive and dynamic occurring beneath one of the most populated coastlines in the United States. Initial studies of the mineral composition surrounding the sinkholes added another layer of urgency. The black porous rock was found to be laced with methane hydrates, volatile crystalline compounds that can become explosive under certain temperature and pressure changes. Such hydrates are known to destabilize ocean sediment and are often found in permafrost or deep-sea continental slopes. Their presence this close to the Florida shelf stunned geologists, raising concerns about the potential for a cascading collapse. If one sinkhole triggered a methane release, it could theoretically lead to an underwater landslide, displacing enough water to generate a devastating wave. This was no longer an isolated phenomenon. It was a ticking clock hidden beneath the surface. What puzzled researchers further was the strange symmetrical layout of the sinkholes. They formed in a loose spiral pattern, as though shaped by some underlying rotational force. The hypothesis emerged that an ancient magma plume or dormant volcanic structure might be reawakening deep beneath the plate, something not previously thought possible in this region. Florida, geologically speaking, has always been considered relatively stable. The idea of volcanic activity, even miles beneath the seabed, was never part of Florida's natural risk assessment. But the heat signatures detected near some of the sinkholes, combined with the structural evidence of forced upward movement in the Earth's crust, pointed toward magmatic disturbances. If true, this would redefine the geological understanding of the southeastern United States. Further complicating matters was the discovery of biological anomalies within the sinkholes. As deep-sea probes descended into the chasms, they transmitted footage of never-before-seen organisms clinging to the walls, creatures adapted to extreme pressure and heat, with iridescent exoskeletons and pulsating bioluminescent patterns. These weren't just rare species, they represented a potential entirely new branch of oceanic life. Marine biologists were astonished. The sinkholes had essentially opened a window into an alien ecosystem, a biosphere that had been sealed off from the surface world for eons. However, some of these organisms appeared highly sensitive to environmental disruption. The sudden exposure of their habitat could lead to extinction-level changes within that micro-ecosystem, or, more alarmingly, allow new invasive species to migrate into surrounding waters. The environmental risks were not confined to biological integrity. With the presence of methane hydrates, heat signatures, and unstable geological structures, the potential for long-term ecological catastrophe became apparent. Entire coral systems could collapse if sediment shifts altered ocean currents. Fisheries that depend on Gulf ecosystems could vanish. Even the Florida aquifer system, which draws from freshwater reserves under the peninsula, could be indirectly affected if the seismic shifts reverberate inland. The interconnectedness of geological systems means that one disruption at the ocean floor can ripple through terrestrial ecosystems in unpredictable ways. The shutdown of the Florida coast wasn't just a security measure, it was a desperate bid to understand a rapidly unfolding mystery before it escalated into disaster. Naval ships with seismographic arrays now hover quietly above the sinkhole field, listening for tremors. Military drones conduct constant flyovers, while satellites relay heat maps and surface changes to control centers. The public has been told only fragments, vague statements about marine geological activity and precautionary environmental protocols. But behind closed doors, the urgency is palpable. This isn't just a Florida issue. If this sinkhole system stretches further, perhaps along the Gulf Stream or deeper into the Caribbean plate, it could affect an entire swath of the Western Hemisphere. Global interest has grown rapidly. Research teams from Japan, Norway, and Chile, countries with significant geological expertise, have offered assistance. NASA has contributed specialized deep-sea imaging hardware, typically used for asteroid impact modeling, to help simulate the effects of potential underwater collapses. Even the European Space Agency has diverted satellite resources to aid in monitoring. It's not just the scale of the event, but the implications that have galvanized international attention. If sinkhole systems of this kind can appear in relatively stable continental margins like Florida, then similar hidden threats may lie undetected in coastal zones around the world. The scientific community is operating in overdrive. Universities across the globe are poring over the data, revising marine geological models and stress testing theories once considered fringe. Theories once relegated to academic obscurity, like the potential for ancient sub-oceanic mantle plumes or deep earth fluid migrations, are being re-evaluated in light of the Florida event. Funding for marine geological research has surged almost overnight, and new exploratory missions are being launched to probe known fault zones with renewed urgency. The Florida sinkholes have become a focal point for a much broader awakening about the unpredictability of Earth's internal mechanics. Amid this whirlwind of scientific activity, there is a growing sense of unease. The sinkholes are not static. Daily reports indicate subtle changes in shape, depth, and chemical composition. Pressure pockets have been detected around the perimeter of the largest hole, suggesting that the geological material beneath is shifting, compressing, or expanding. In some cases, acoustic readings suggest subterranean movement, like giant stones grinding in darkness. These auditory signals are faint but unmistakable. Something beneath the sea is still very much alive and changing. There is no consensus yet on what exactly triggered the formation of these terrifying sinkholes. Some suspect long-term geological stresses finally breaching a critical threshold. Others point to climate change, which has been altering sea temperatures and ocean pressures in unpredictable ways. More speculative theories suggest that human activities, deep-sea drilling, seismic testing, or even offshore construction may have weakened the already fragile structure of the seabed. But one thing is clear. Whatever has been awakened beneath the Gulf of Mexico, it is powerful, mysterious, and potentially dangerous. Florida's once serene coastline, lined with resorts and marinas, now faces an invisible threat lurking just offshore. Tourists have been quietly evacuated from certain areas. Coastal real estate developments are under review. Insurance companies have begun to adjust their risk calculations. Every boat that once passed over the calm waters of the Gulf now sails over what may be the entrance to a geological time bomb. This is no longer about curiosity or research. It is about preparedness and survival. The sinkholes have become a symbol of Earth's hidden volatility, a reminder that even in the 21st century, there are realms of nature we have not yet charted, let alone understood. As the sinkholes continue to evolve, as pressure builds beneath the crust, and as new data pours in, one chilling reality remains undeniable. Florida's coastline now sits on the edge of an abyss whose full depths we have only just begun to comprehend. In the days following the discovery, the scale and complexity of the sinkhole phenomenon only deepened. Each subsequent scan revealed not just new sinkholes, but entire layers of subterranean caverns that twisted and stretched outward from the main formations. Unlike surface-level sinkholes that collapse suddenly and visibly, these deep ocean anomalies appeared to form with eerie silence, carving vast hollow spaces beneath the seabed. Seismic instruments, redeployed in denser arrays around the exclusion zone, picked up low-frequency vibrations that pulsed in rhythmic intervals. They were not strong enough to trigger alarms, but regular enough to hint at something deeply mechanical, almost like a slow, grinding breath emanating from the Earth's crust. Advanced bathymetric mapping painted a chilling image. Beneath the seafloor lay not a single void, but a complex network of interlocking chambers and fissures. These features bore little resemblance to the chaotic collapse typical of sedimentary erosion. Their layout had geometric consistency, as though molded by pressure systems or thermal flows rather than random degradation. The deeper the probes went, the more erratic the magnetic field readings became. Scientists observed small, localized anomalies, blips in the Earth's magnetic field concentrated around certain sinkhole mouths. Though not yet understood, these fluctuations indicated the possible presence of subterranean metals or mineral compositions not yet classified in this region. Even more perplexing were the subtle chemical traces found within water samples taken from the depths of these holes. Elevated levels of isotopes typically associated with hydrothermal vents, such as helium-3 and certain rare earth elements, suggested a deep mantle connection. But Florida's seafloor had never been considered a hotbed of tectonic interaction, let alone mantle upwelling. The sheer improbability of finding such signatures in this part of the Gulf stunned geochemists. If these traces were accurate, it could mean a fracture in the lithosphere far more profound than previously imagined, exposing Earth's deeper layers through pathways that had remained sealed for millions of years. This revelation drew a new wave of scrutiny. Geologists began to compare satellite gravity measurements across the Gulf with historical data. Subtle shifts in mass density were recorded, supporting the theory that the ocean floor was undergoing deformation at a regional level. The slow redistribution of weight, water pressure, and tectonic tension was no longer confined to isolated points. It was moving laterally, in silent but relentless waves beneath the continental shelf. These movements hinted at a potential basin-wide reconfiguration. The Florida platform, long thought to be geologically dormant, was no longer passive. It had become an active player in the Earth's dynamic internal processes. Civil engineers and coastal planners, once on the periphery of such scientific inquiries, were quickly drawn into the fold. Florida's infrastructure, its roads, bridges, canals, and seawalls, had been designed under assumptions of geological stability. Now those assumptions were being erased. Engineers began recalculating risk profiles. accounting for ground resonance that could transfer from sea to land. Subsurface tremors, once considered inconsequential, now posed a potential threat to high-rise buildings built atop reclaimed land or porous limestone. Ground-penetrating radar was deployed across several counties to search for signs of terrestrial echo formations, land-based sinkholes or cavities that might mirror those discovered offshore. Meanwhile, the ecosystem itself began showing signs of unease. Dolphins and fish were observed migrating erratically, abandoning familiar breeding grounds and reef systems. Oceanographers studying nutrient plumes in the area noted a sharp deviation in currents around the exclusion zone. Water temperatures fluctuated at levels too deep to be influenced by weather, implying that some unknown geothermal force was stirring from beneath. Coral reefs near the outer rims of the sinkhole network began to pale, not from bleaching due to surface warming, but possibly from changes in deep-sea chemistry or pressure anomalies. The cultural and economic ripples of the shutdown spread rapidly. Florida's economy, heavily reliant on marine traffic, tourism, and fishing, began to feel the first waves of disruption. Commercial fisheries were grounded indefinitely, forcing suppliers to seek alternative ports in neighboring states. Cruise liners diverted their routes, some canceling Florida landfalls altogether. Ports along Tampa, Naples, and Clearwater faced growing queues of container ships redirected at the last minute. The logistical strain began to affect supply chains, especially those dependent on perishable goods like seafood and fresh produce. Local businesses, once bustling with beachgoers, found themselves eerily empty, their views of the glimmering Gulf now underlain with dread. Amid growing public speculation, the government ramped up containment and information protocols. Satellite imagery of the region was placed under restricted access, and scientific reports from research vessels were subject to review before public release. This strategy, meant to prevent panic, only fueled speculation. Independent researchers and citizen scientists took to online platforms, sharing grainy sonar snapshots and depth profiles. Forums buzzed with theories, some plausible, others outlandish, about the origins of the sinkholes. From theories of undiscovered fault systems to speculation about ancient submerged cities, the narrative expanded far beyond the bounds of science. Yet even the most grounded experts couldn't fully account for the speed and scale of the event. What had begun as an unusual geological formation had evolved into a phenomenon that challenged the very frameworks used to understand Earth's crust. At its core, this was no longer just about sinkholes. It was about planetary behavior. Deep beneath the ocean floor, ancient pressures long thought dormant were mobilizing, reshaping the interface between land and sea, sediment and magma, history and catastrophe. The international response continued to scale alongside the threat. The United Nations Commission on Oceanic Safety issued an unprecedented advisory, urging coastal nations to reassess their underwater terrain for similar risks. Countries with complex offshore geology, such as Indonesia, Iceland, and New Zealand, began revisiting archived seismic data, now with fresh eyes. This wasn't just an American dilemma anymore, it was a global wake-up call. If Florida could harbor such hidden instability beneath its tranquil waters, then no coastline could be considered immune. New technology was rushed into development. Deep-sea resonant sensors, devices that could detect and differentiate between types of subterranean motion, were fast-tracked for deployment. A multinational research platform, hastily repurposed from an Arctic drilling vessel, was dispatched to the Gulf to establish a mobile observation hub. This vessel, equipped with particle detectors, AI-powered mapping tools, and sub-ice sonar, began operating around the clock, feeding terabytes of data to research centers around the world. Even private aerospace companies joined the effort, offering high-altitude drone fleets to monitor surface anomalies with minute precision. At the heart of all this technological and scientific fervor was a single driving force: the unknown. Every new scan, every chemical assay, every seismic echo fed into a growing tapestry of mystery. And at the center of it all were those dark, gaping holes, silent, immovable, yet alive with the promise of something ancient and transformative. Not just in a destructive sense, but perhaps in an evolutionary one. What lay within those shafts might not simply be geological structures, but archives of Earth's past, sealed vaults of chemical history, biological evolution, and tectonic memory waiting to be unearthed. In this frenzy of discovery, some researchers began to suggest that the sinkholes could be part of a process known as subcrustal reorganization. This theory posits that deep within tectonic plates, energy and material sometimes redistribute in sudden bursts, reorganizing the configuration of mass beneath the surface. It's a poorly understood process, usually attributed to hot spots like the Hawaiian mantle plume. But here, beneath Florida, it was now being proposed as the source of the Gulf anomalies. If validated, this would mark the first known instance of subcrustal reorganization occurring under a passive margin, a tectonic region previously dismissed as uneventful. The possibility that such profound shifts could occur silently, without warning, changed the tone of the entire investigation. No longer was this a matter of measuring collapse or cataloging sinkholes. It had become a race to understand a new kind of geodynamic behavior. The Earth was speaking through deep rifts and shifting heat, and the message was clear. The old rules may no longer apply. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Florida being shut down over oceanic sinkholes? We want to hear from you. Thank you for watching and see you next time.